You know, sometimes you hear about animals that feel almost mythological, things you see in books but can't quite believe are real.
Hmm.
Well, actually, swimming into a live anglerfish, specifically a humpback anglerfish, that's like hitting the absolute jackpot in nature watching.
Oh, absolutely. Winning the lottery for sure.
Yeah.
It's a creature seen alive so rarely.
Mm.
Any sighting is huge news instantly.
It really is a proper deep sea legend.
Definitely. I mean, anglerfish are famous everywhere, mainly because they look so, well, freaky, right?
Totally.
But for scientists, still kind of a black box. So much about how they live, how they breed, even how many there are.
Mm.
It's mostly mystery.
And that's exactly what we're diving into today. We're going to look at this amazing recent sighting, this viral moment,
Right.
and then we'll really unpack the fish itself. You know, the extreme adaptations, that terrifying look, the just bizarre biology that makes it one of the strangest and honestly successful things swimming down there.
It's going to be fascinating.
Our goal is to give you that deep analytical look, the shortcut to understanding what makes this creature tick. Okay, let's get into this story.
Let's do it. So picture this. Earlier this year, off Tenerife Island in the Canaries,
Okay.
we've got this photographer, David Jara, and he's with friends, including a marine biologist, Laia.
Right, so they're professionals out on the water.
Yeah, but they weren't even looking for an anglerfish. They were actually out trying to find blue sharks. Spent the whole day looking, found nothing, and they were heading back in. Pretty disappointed, probably.
Ah, the classic end of the day finds.
Exactly. Just as they're packing it in, Laia spots something, a sort of black shadow
Yeah.
right there on the surface.
On the surface. For a deep sea fish.
That's the thing. They stop the boat, get closer, and boom, they realize it's a live anglerfish.
Wow.
The shock, the excitement. You can imagine. They knew instantly this wasn't just any fish. This was the legendary animal.
And Jar's reaction, this is the part of the story I love. It just shows the passion.
It really does.
Yeah.
The water was freezing cold, absolutely freezing.
Uh-huh.
But he was so stunned, so determined to capture this moment. He just strips off his clothes, down to his underwear.
No wetsuit or anything.
Nothing, just underwear. Jumps straight into that icy water as fast as he can, camera in hand, desperate to document it.
That's dedication. Seriously. Just, wow. In his underwear.
And just those pictures, that video, that went everywhere. That's a real commitment.
So the fish itself, you said it was on the surface. What did it look like? How big was it?
Well, that's another clue. It was tiny, really small, only about 6 centimeters long.
6 centimeters. That's barely anything.
Right. And, the fact that this deep-water fish, something that lives thousands of feet down, was even near the surface, that was a huge red flag immediately. It wasn't a good sign.
Yeah, that's the sort of tragic side of this amazing discovery, isn't it? It was clearly not well.
Not at all. It was in really bad shape.
Yeah.
The researchers describe it as screaming in a bizarre way, sort of bobbing up and down right at the surface.
Screaming, like, audibly.
Well, maybe not literally screaming, but thrashing, distressed. Its skin was broken in places, too. Probably from the pressure change, the different environment, just too much stress.
Oh, that's tough. So what happened to it?
Sadly, yeah, it died
Hmm.
right there while they were filming.
Oh, man.
But, even in death, its scientific journey was just beginning because it was such an incredibly rare thing to find.
They collected it, right.
They did. Collected it immediately, took it straight to the Tenerife Museum.
And I read they made an interesting decision there. They didn't cut it open for a necropsy.
That's right, an important choice. They decided to preserve it whole.
Why is that significant?
Well, it means the fish stays intact as this perfect example of biodiversity. But crucially, it also means future scientists, maybe decades from now, can use new techniques we haven't even invented yet for genetic research on it.
Ah, I see. Preserving future possibilities. That makes sense.
Exactly. So think about it. We started with this one tiny 6-centimeter fish and the sheer rarity of seeing it.
Yeah.
If seeing just one is such a big deal, how much do we really not know about the whole order of these fish? The lophoforms, I mean. There are hundreds of species.
That's the perfect transition, because if you're a fish living way down there in the dark, you need some serious tricks up your fin.
You definitely do.
Let's talk about the most famous feature, that creepy glowing lure. What's the science behind that? How does it actually work in total darkness?
Okay, so that lure is called the esca. And the key thing to understand is it's not just the fish's own flesh glowing.
No.
No. The anglerfish actually partners up with bioluminescent bacteria. It hosts them, cultivates them right there inside the esca, and those bacteria produce the light.
So it's like a little deep-sea farmer growing its own light source?
Kinda, yeah. It's a symbiotic relationship. And it's not for seeing its way around like a headlight.
Right, it's bait.
Purely bait.
Yeah.
A dedicated follow-the-light trap. Little fish, crustaceans, they see this faint glow, maybe think it's the smaller critters than they eat.
Mm-hmm.
They drift closer, slowly, and then bam.
The attack.
The attack. That massive mouth snaps open and shut incredibly fast.
Yeah.
We're talking milliseconds.
Wow.
It creates this powerful vacuum effect that just sucks the unsuspecting prey straight in. Whole.
Terrifyingly efficient. Just inhale your dinner.
Quick, decisive, no messing around.
But even with this incredible tool, the esca, there are still big questions, right? We see it works, but the how is fuzzy.
Oh, definitely. Huge puzzles remain. Like, how does the fish even get those bacteria in the first place?
Good question.
Best guess. Probably just filters them from the seawater when it's young. But nobody's actually proven it. It's still a hypothesis.
And controlling the light, can it turn it up or down, flash it?
We assume it must have some control, maybe chemically, maybe by restricting blood flow.
Mm-hmm.
But the exact mechanism, still unknown. And think about this. When the light's off, maybe to save energy or hide, how does it navigate? How does it find anything in that complete, utter blackness?
Which suggests it must have other senses ramped up to 11.
Exactly. Because down there, food is so incredibly scarce, so you can't afford to miss a chance.
So when they do catch something...
They make it count. That huge mouth isn't just for show. And their stomach. It's incredibly stretchy. They can swallow and digest prey almost as big as themselves.
But here's the kicker, right? The thing that really shows how tough life is down there, most anglerfish that get caught, like in deep-sea nets,
their stomachs are empty. Completely empty.
it tells you they spend most of their lives just waiting, floating, hoping for that one big meal. It's feast or famine, literally.
Which makes detection absolutely critical. You need to find that rare meal. So some species have developed these amazing mirror eyes.
Mirror eyes, like in a cat.
Sort of similar, yeah. It's like the tapetum lucidum in cats or dogs. A reflective layer behind the retina bounces light back through it, gives the photoreceptor cells a second chance to catch every single photon, maximize whatever tiny bit of light there might be.
Incredible, but what if there's zero light? Absolutely none.
Well, then they rely on something even cooler, a kind of sixth sense. Their bodies are covered in these tiny sensory pores.
Okay, what do they sense?
They can pick up changes in water pressure, salinity, sure. But the really amazing part, they can detect the tiny electrical signals given off by the muscle contractions of other animals moving nearby.
You're kidding. They can feel other creatures' nervous systems.
Essentially, yeah. They don't need to see you. They don't need to hear you. They can feel you moving in the water through your own bioelectricity.
That is mind-blowing, a true alien sense.
And it ties into their whole energy strategy, doesn't it? This reliance on stillness, on sensing rather than actively hunting.
Right. They barely move.
Exactly. Look at their fins. The pelvic and pectoral fins are tiny, almost conical. They're not for powerful swimming. They're for making tiny adjustments, just enough to hover almost perfectly still in the water column.
Saving every possible calorie.
Every single one. Because energy is the ultimate currency down there.
Which brings us back to that fasting question. How long can they go between meals? It's still a mystery.
It really is.
Yeah.
We know they have fatty deposits and super low metabolic rates. But they don't have those huge oily livers like deep-sea sharks use for long-term energy storage. So the precise chemistry, the trick that lets them survive potentially months or longer without eating, we still don't fully understand it. It's a fundamental puzzle about deep-sea life.
Okay, so we've got the lure, the vacuum mouth, the electric sense, the extreme energy saving.
Yeah.
All driven by that intense deep-sea environment. And that same environment led to maybe the weirdest adaptation of all, their sex lives.
Boy, yeah. Sexual parasitism.
Yeah.
Something else.
It sounds bizarre, but when you think about the environment, pitch black, huge spaces, very few fish.
Finding a mate must be incredibly difficult.
Right. You might literally only bump into a potential partner once in your entire lifetime.
So evolution's solution. Make that one encounter count. Permanently.
Although, quick clarification, it's not all anglerfish species that do the permanent attachment thing, is it?
Good point. No, not all of them. In some species, the male just sort of hangs around the female for a while, waits for her to spawn, and then leaves. Less dramatic.
But in the extreme cases,
Right,
like
yeah.
the warty sea devil, that's where it gets really wild.
Totally wild. So the male is way, way smaller than the female. Tiny, often.
Right.
He finds her, By smell, basically. Follows her pheromones through the dark.
Okay, he finds her, then what? This is the crazy part.
This is the crazy part. He bites her anywhere on her body, and then he releases enzymes from his mouth.
Uh-huh.
And these enzymes literally digest his own mouth tissue and the female's skin where he bit her, causing them to fuse together permanently. Their circulatory systems connect.
Wait, they fuse? Like biologically merge?
Only merge. It's not just sticking on, it's becoming one organism in a way.
It's utterly bizarre.
Yeah.
It's biological hijacking.
It really is. And the male's transformation after that is extreme. He goes blind, his fins wither away, all his internal organs, his digestive system, everything. It all shuts down and atrophies, except his testes. They actually grow larger. His entire existence boils down to one thing: providing sperm whenever the female is ready to reproduce.
So the female provides all his nutrients through their fused bloodstreams.
Everything he needs to survive. He becomes, and this is how researchers put it, essentially a living scrotum attached to her body.
Yeah. Wow. A living scrotum. That's stark.
It is, and get this. Because mates are so rare, sometimes a single female might have multiple males fused to her.
Seriously, like collecting them.
Yeah. Little parasitic males attached all over her body ensure she's always got sperm ready to go whenever conditions are right for spawning. Deep-sea polygamy via parasitism.
How on earth did something that extreme even evolve? These fish, the Lophiiforms, they've been around a long time, right?
About 100 million years, yeah.
Yeah.
The hypothesis, it started gradually. Maybe early on, males that just stuck around females longer after finding them had better reproductive success.
Because they were there when she was ready to spawn.
Exactly. So maybe being a bit clingy gave an advantage. Over millions of years, natural selection favored males that stuck closer for longer.
Until clingy became permanently fused.
Pretty much, that tendency just got pushed to the extreme, becoming this obligatory fusion we see in some species today.
You can almost see an earlier version of this body plan in their shallower water cousins, right? Like the monkfish.
Yeah, the monkfish is a great comparison. It's got the big mouth, the ambush style, hides on the bottom. But it lives where food is more common.
So it never needed the fancy light lure.
Didn't need the lure and didn't need the extreme sexual parasitism because finding a mate isn't quite such a once-in-a-lifetime challenge. It's like a baseline anglerfish model.
But that raises the final big question, doesn't it? If the deep sea is this sort of uniform environment, dark, cold, high pressure, why are there so many different kinds of deep sea anglerfish? Hundreds of species.
Right. Why isn't there just one perfect deep-sea anglerfish design that outcompeted all the others?
Yeah, why all this variety down there? It's a huge evolutionary puzzle.
It is. And one fascinating idea scientists suggest is maybe we're just looking at it wrong. Maybe we're just too terrestrial.
Meaning?
Meaning our senses are tuned for life up here. Down there, maybe tiny variations in water chemistry, temperature gradients, pressure zones, things we can barely detect, are actually huge environmental factors driving diversification.
So the abyss might seem uniform to us, but to the things living there, it's actually a really complex, patchy landscape.
Potentially, yeah.
Uh-huh.
Highly nuanced, varied, competitive in ways we just don't perceive.
Yeah.
We lack the biological equipment to fully appreciate the subtlety of their world.
So let's try and wrap this up for everyone listening. We started with just how incredibly rare it is to see one of these things alive.
A true needle in a haystack.
Then we dove into the bizarre reality, the lure made of bacteria, the vacuum cleaner mouth, hunting by feeling electrical feel.
And the extreme energy saving.
And finally, that unbelievable sexual fusion, becoming one organism to beat the odds of finding a mate. These are creatures truly sculpted by the extreme.
Absolutely. Redefining survival.
And that final mystery you mentioned, the sheer variety of species, it just underscores how little we still know, doesn't it?
It really does. It points to the vastness, the sheer unexplored nature of the deep ocean, the number of anglerfish species, the fact we still wonder if they have any kind of social interactions. It all proves how much we have yet to grasp.
It makes you think, doesn't it? What else is down there, in the cold and the dark?
Exactly. How much life, completely unlike anything we can easily imagine, is just waiting for us to finally find it and understand it. It's a universe hidden beneath the waves.